Hello, Math Study students, and welcome to your online lesson. Today we'll be moving on to solving quadratic equations using the factoring techniques that we've looked at in the last several video lessons. We will know we are successful when we can efficiently solve quadratic equations. So a quick reminder, our quadratics, of course, have x squareds in them. We have looked at quadratics that have a terms, no a terms, missing c terms, all sorts of different things. But again, today we're going to be really talking about equations. And so the equations have to have an equals, and in general, we're going to have those things equal to 0 before we solve them. When solving linear equations, and by linear equations, I'm talking about like freshman algebra problems, 2x plus 1 equals 5, an example like that, generally a single variable. Our goal is always to isolate the variable. That means get it by itself. So get the variable alone. So for example, we could subtract 1 from both sides here, move my work over here. I have 2x then equals 4, divide by 2, and now I just have x equals 2. So we're getting the variable alone to find its value. Okay, now that is not the case when we deal with quadratic equations. So whatever techniques that we've used there, that will not be the main overall theme for what we're doing here today. For quadratic equations, we needed to get the equation equal to 0. And we saw that on that previous slide where, again, we will often have quadratics equal to 0. And then the next step is going to be factoring. And only once we factored it, then we set each of the binomial factors equal to 0 as well. And then we're often going to have two possible values for our variable, which will often be x. So a little different than what we have done. There will be a little algebra involved, but only after we've factored it and set those binomials or factors equal to 0. So why do we set the binomials equal to 0? Well, let's take a look at the following equation. I've got two variables here, x times y equaling 0. So xy equals 0. Let's think about this for a second. What does x or what does y have to be if we equal 0? So let's say that x was 5. So we had 5y equals 0. Well, what does y have to be to make 5 times y equal 0? Well, we could use algebra to solve this. Divide both sides by 5, and I get y is equal to anything divided by 0 is 0. So let's check that. 5 times 0 equals 0. But it doesn't have to just be a 5 there. In fact, it could literally be anything there. It could be 10 times 0 equals 0, 20 times 0, or it doesn't even have to be the y that's 0. It could be x. But the important thing is that one or the other one of these variables must be 0, because when you're multiplying, the only way to make an answer equal 0 is to have one of the two things that you're actually multiplying also equal 0. Now, as we look at an actual quadratic that's already been factored, so we can see it's got two binomials, those sets of parentheses. X plus 2 is one of the binomials with two terms, x minus 1 is the other, and we have those equal 0. What must either one of those binomials equal? Well, again, if let's say this first binomial was equal to 0, so we'd have x plus 2, we're replacing that with 0, and if we multiply 0 times x minus 1, well, 0 times anything, whether it's an x or a 1 or anything along those lines, is going to be 0. And so you'd end up with having 0 equals 0, which is absolutely true. Now, it doesn't just have to be that binomial that equals 0. It could also be the other one that's equal to 0. And so we could say that this second equation, or second binomial, I guess would be more accurate, x minus 1, we could let that equal 0. And so then we would have x plus 2 times 0 equals 0. And once again, 0 times anything, whether it's a 2 or an x or anything like that, is just going to be 0. And then we'd have a true statement. So again, our goal is to take these binomials, either one of them, in fact both of them, and set them equal to 0 to find out what possible values of x are. Now looking at this, you might say, well, how do you actually make one of those binomials 0? Well, right away you could see that what number could we plug in for x that would cancel out a 2 or make it go away? And the answer would be negative 2. And then here, what value of x could we plug in that would make a negative 1 or a minus 1 go away? And that would be a positive 1. So if I have a negative 2 plus a 2, I would have 0, and 0 times anything equals 0. Or I could plug in a 1, and I'd have 1 minus 1, which equals 0. And again, 0 times anything equals 0. And we'll look at some more specific examples of that. But that's the big picture idea. Do you really need to understand the big picture idea to do this? Probably not, but it certainly doesn't hurt. So this is a slide you may want to pause on and get in your notes. These are the steps we're going to use to solve a quadratic. Now, these are not the same as the steps we use to factor a quadratic. This is solving, meaning finding values for our variables. So first thing we want to do is get the quadratic equation equal to 0. Sometimes they'll already be equal to 0, but if not, you're moving all the terms, anything with an x, anything with a constant, over to the other side, combining any like terms if that hasn't already happened, and then you're going to have nothing, or a 0 essentially, left on the other side. I usually move all my stuff to the left side of the equal sign, so my 0 is on the right, but you could do it in either direction. Then we're going to factor the quadratic. If you're not sure how to factor, you can look back at the last 3 videos that we've had, which talked about different types of factoring. Then we'll set each of the factors, which will usually be a binomial, equal to 0. So we're writing a separate equation off to the side, solving for that, which will usually just be basic algebra, or sometimes like railroad track sort of math, where you're getting stuff across to one side or the other. And then we will list both answers separated by a comma or the word or. So on that last slide, we saw that we had x was possibly equal to negative 2 or 1. You could also do that as negative 2 comma 1, but not negative 2 comma 1 as an ordered pair, because that would be thinking like an x and a y, which is not what we're dealing with here. This would probably be the preferred way, but we'll see this often here with a comma. Finally, plug your values in and check those in the original equation just to make sure that you've done everything correctly. So there's no confusion, especially like on a test. We know whether we did it right if we check that answer. So let's start off with this first one here. Solve the following quadratic equation. We know it's an equation because there is an equal sign. Secondly, we know it's a quadratic because it has an x squared. Also, it does not have a value as an a term, so it's just an implied one. So this should be a relatively easy one to factor. There are negatives, though. So I'm going to start off with my c term, since there is no a term other than the implied one. And so I have negative 10. I'm going to list the possible factors, ignoring the negative for now, starting with 1 and 10. Next biggest number to go into 10 is 2, which is 5. 3 and 4 do not go evenly into 10. And then we get back to 5, which is already listed in our pairs of factors. Now, it's a negative c term, which means one of our factors has to be positive and one has to be negative. When you multiply different signs, they become negative. But we know they have to add to be our b term, which is positive. So the bigger number must be positive. So as I add these together, it's clearly the second set of factors that are going to be my choices here. So I can write those down. Excuse me. I've got x minus 2 as my first binomial, and then I have x plus 5 as my second. And of course, don't forget your equals 0. All we did was mess with the left side, which is where our quadratic was, but we're going to bring down the equal and the 0. Now, if my only directions were to factor, I'm done. However, our directions say solve. So we need to actually solve this. So we go on to our next step, which is to take each one of our factors, or binomials, and set them equal to 0. So my first binomial is x minus 2. I'm going to set that equal to 0. I have a second binomial, x plus 5. I'm going to set that equal to 0. Now, you might be able to just do this in your head, sort of like I was doing on the last slide, but we can always use algebra. Since I'm subtracting 2, to undo that, I'm going to add 2 to both sides to isolate this variable. X equals 2. And then I have a second possible answer over here for my second binomial. I'm going to subtract 5 from both sides to isolate that variable, and I get x equals negative 5. So my final answer, x can either be 2 or negative 5. Now, I can, of course, check these by going back to the original equation and plugging them in. So for our check, we will simply go back to this original equation and plug in our values. So we had x squared. Well, what is x? Let's start with 2. We have 2 squared plus 3 times x. Again, x is 2, and then we have minus 10. And all of that should equal 0. Well, 2 squared, I'm going to write the answer above it, is 4. 3 times 2 is 6. and then we're subtracting 10. Well, 4 plus 6 is 10, and then we subtract 10, we end up with 0. So it absolutely checks out. We can do the same thing with our negative 5 now. I'm simply just going to try to clean up what I wrote here and reuse some of that work. So I have a negative 5, this time squared. Need parentheses because the negative is also getting squared. Then I have 3 times my negative 5, and then minus 10. So negative 5 squared, negative times a negative gives me a positive, so I have 25. 3 times negative 5 gives me negative 15, and then minus 10. Well, you'll look here, I have a minus 15 and a minus 10, which if I add those together, I have a minus 25, and 25 minus 25 gives me 0. So once again, these solutions both make this a true statement. 2 possible answers. Moving on to our next example. Now this one, we do have an a term for our quadratic, and so we have to do the slightly longer method for factoring. But also, before we even get to that, take a look here. Our equation is not equal to 0. In fact, it's equal to 12. And so the first thing that we need to do is get all of our terms over to the left side. So to get our 12 to the other side so that we just have a 0 on the right side of the equation, we're just going to do old school algebra, subtract 12 from both sides. These will cancel out, leaving nothing, but I can't just put nothing there. And again, 0 is what we want to have. And now you'll notice I have 3 terms. I have 2x squared here on the left, I have a positive 5x, and a negative 12. We'd like to write those in descending order, meaning our highest exponent of x is first, 2x squared. That's like our a term, plus just our 5x, our b term, and then minus 12, which is our c term. None of those can be combined because they're not like terms. I have 2 x squareds, 5 regular x's, and then minus 12 as a constant. Now it's ready to go. However, like I said, we do have an a term on this one. We have a 2 and a negative 12, so we have to factor using our most recent technique. And to do that, we're going to take 2 times negative 12, which gives me negative 24. We're going to list the possible factors of that, again, ignoring the negative to start with, and we'll come back to it. 2 and 12, 3 and 8, 4 and 6, and 5 does not go into it, and 6 we already have up here. So those are all of our possible factors. Now I ask myself, okay, so it was negative. I must have one negative and one positive to multiply together to be this negative 24. But when they add, they have to be this positive 5, which means my positive must be bigger. As we go through this, we're going to have 23, 10, and 5. That was the one we wanted right here. So for this one, we don't write our binomials yet. We split apart that b term. So I'm bringing down my a term, 2x squared. The 5x we're going to rewrite as negative 3x and positive 8x, and then minus 12 equals 0. Now we're going to look for monomial factors that can come out. I'm going to write some buckets here. 2x squared and negative 3x. Really the only thing I can pull out is a single x, leaving behind 2x minus 3. Again, when we distribute that x back in, it'll become a 2x squared, and when we multiply the x times the negative 3, I would get this negative 3x here. On my second group of terms, I've got 8x minus 12. Well, in this case, 8 and 12 both have a common factor. They're both even, so I know 2 goes into it, but even better, I can pull out a 4, leaving behind a 2x and a minus 3, because again, 4 times 2x would get me back to the 8x, and 4 times negative 3 would get me back to negative 12. Most importantly now, looking at what's left over in these binomials, they are identical. So I can make my final binomial answers. So I have x plus 4, which were the monomial factors I pulled out, and then the leftover binomials, which are the same, I can write them a single time, bring down my 0, to actually have my equations. Now, unfortunately, we're not done yet because though we factored it, we have not solved it. So we need to take each of our binomials, each of our factors, x plus 4, and set that equal to 0. And then my other one, 2x minus 3, and set that equal to 0. I subtract 4 from both sides. I get x equals negative 4. Over here on the right, I'm going to add 3 to both sides to get my 2x alone. 3 to both sides. Those will cancel out. I have 2x equals 3. Divide both sides by 2, and I get x equals 3 halves. Could I turn that to a decimal, 1.5? Sure. I won't, though. Could I make it a mixed fraction or mixed number? Absolutely, 1.5. But again, I'm not going to. A nice ratio of 3 halves is the easiest way to leave it, and also the easiest to work with. All right, now I could check both those answers by plugging them in. For the sake of time on this video, I am not going to do that because I do want to look at one last example here. For our very last example, this one looks really short. It barely even looks like a quadratic, but you will notice it does have an x squared, even though it is not set equal to 0. So to solve this one, we will simply move the 8x over to the same side as the 4x squared. And I'll do that with, again, our sort of old school algebra, or railroad tracks, as some people call it, where we're dividing everything in half. The 8x's will cancel out, leaving nothing behind, also known as 0, which is what we wanted. And now we have 4x squared minus 8x equals 0. Quadratic, equal to 0. So now we can solve this by factoring. But remember, there's no c term here. There's no constant. So we can do our monomial factoring here and ask ourselves, what term can we pull out from both 4x squared and negative 8x? Again, they're both even, so I could pull out at least a 2. In this case, I'm going to pull out a 4. They both have an x, so I can pull that out as well. Now, what's left behind? From our first term, the 4 has been pulled out. It was x squared. We pulled out one of those x's, so one x is left. For the negative 8x, we pulled out a 4 and an x, so that would leave a negative 2 behind. Again, we can check our work by distributing. 4x times x gives me 4x squared. 4x times negative 2 gives me negative 8x. Now we can take each of our factors, one of which is that monomial factor 4x, set that equal to 0, and then take x minus 2 and set that equal to 0. Well, to get x alone here, all I do is divide by 4, and I get x equals 0, because anything divided by 0, or 0 divided by anything is 0. And then simply add 2 to both sides here, and I get x equals 2. So our final answers are x equals 0 or 2. All right, that is our lesson for today. We have learned to solve quadratic equations using factoring techniques, and we looked at a variety of different problems where we got into practice efficiently solving quadratic equations. Till next time.